Alright guys, today we're going to be going over horizontal projectiles. You should have already looked at the projectile basics video and learned how to draw a motion diagram for a projectile that's been launched horizontally. If you haven't, please make sure to go back and review that, make sure you understand it, because I'll be just assuming that that totally makes sense to you. And if it doesn't, you might find this a little bit confusing. But what we're going to do here is we're going to try to take that a step farther and actually do some calculations related to an object being launched horizontally. So what we want to think about is maybe like a ball being rolled off the edge of a table. We're given its initial velocity, which is completely in the x-axis, completely horizontal, and we're also given the height that it's going to fall. And what we want to find is the distance traveled for that ball. So how far is it going to actually launch out this way? And we need to realize one thing is that the distance traveled that we're talking about here is actually the delta x. We're talking about how far in the x direction did we go. Alright, so one of the first things that I like to do with that is to draw out a chart, because this is a two-dimensional problem. We've got both the x and the y dimension that we need to worry about. So I like to make a little t-chart just to keep track of the different variables that we might have to worry about. Now when I talk about variables, I mean variables in these different equations right here. You should be familiar with these four equations. I tend to recommend that you simply memorize them, though of course they are based on some basic calculus and you could derive them if that's one of your strengths. But for the AP Physics C exam that we're all practicing for, I don't think it's worth it. So just memorize these. Alright, so when we look at these equations, the different variables that we're worried about are the position, delta x, or delta y, respectively, the initial velocity, what I'm going to call VOX, or V naught x, and VOY, the final velocity, Vx and Vy, the acceleration, AX and AY, and then the last thing that we worry about is the time. And I like to draw the time in between these two categories, because we need to realize that time is actually something that unites these two. It's not part of the x-axis, it's not part of the y-axis, it's actually its own dimension. So we can actually go through these and get kind of look at which of these are given to help us set up our equation. So that's what we're going to do. First of all, I've definitely been given the initial velocity of this object. And that actually, we want to realize, because it's in the x direction, represents the VOX. So we'll just write VO right there. The other thing that we're given is the height, which is going to represent delta y. So we can plug that in there. Now, to go through these other things, delta x is what we're trying to solve for. We want to know the distance that we're going to travel. The initial velocity in the y direction is going to be 0, because we are not traveling in that direction at all, just horizontally. Acceleration in the y direction is always going to be g for a projectile. Whether you want to call that 10 meters per second squared or 9.8 meters per second squared, I don't care, but let's just make it g. By the way, for the AP Physics C Mechanics exam that we're worried about here, they call it 10. Alright, so I'm just going to write g. Also, to indicate that this acceleration is downward, I'm going to make that negative g. As far as velocity in the y direction, the final velocity, I do not know what that is, so I'm just going to simply leave that blank. Then for acceleration in the x direction, it's important to realize that the acceleration there is 0, because the speed is not changing horizontally. Again, that's true for all projectile problems. So this little section, right there, you can always fill that in that way. Whether it's a horizontally launched projectile or vertically launched, it doesn't matter. That's going to be the acceleration. Okay? Now, The other thing that we can add here is because the change in speed is 0, if the initial speed is VO, then the final speed is also VO. So we can add that in. That helps us to use some other equations that we might not be able to otherwise. And then as far as time, we don't know that either. So when we look at all of this, we got one thing that we're trying to solve for, you got two missing variables. And so what we need to do is we need to fill in a little bit more of this information. And here's why. If I were to just plug this x information in for delta x, it wouldn't help. I'd be asking how far do you have to go to speed up from initial velocity of VO to final velocity of VO? And the answer is you don't have to go anywhere because you're already moving at that speed. And so I can't use this equation to figure out delta x. It's not the horizontal motion that determines when this whole thing stops. It's the vertical motion, because horizontally you don't hit anything and vertically you do. You hit the ground. So we need to start with vertical motion. What we're going to do is try to figure out something over here that will connect to the horizontal motion. And what we're talking about that in that case is the time. So we're first going to use the vertical motion to solve for what I like to call the air time, or the hang time. It's just how long is the object still a projectile. And that's typically something that you'll do in projectile problems if you're not given the time. It's always a very powerful thing because it's the only variable that has to be the same in both axes. Once I've solved for the time, then I can use that time in order to tell me how far I'm going to go. And basically, I'm just going to say, hey, if I'm traveling 5 meters per second and I'm traveling for 4 seconds, then I go 20 meters or so on and so forth. So step 2, just solve delta x. Okay. Now, you've got these 2 steps, you've got the given information, you've got the equations. You can probably put all of that together into an expression for delta x. I recommend that you give it a shot, see how it goes, and then look at my video, Horizontal Projectiles 2, in order to see how I solved it and see if you did it the same way. That's going to be the most helpful thing for you because, hey, you might find out you're smarter than you thought you were.